All right, I'm Cathy Bruce from Trent University, where I teach mathematics methods courses, and if you want to follow me on Twitter, you can see that at Dr. Cathy Bruce. The resources and the work that my team does are featured on the Teamwork website, and my relentless question is this: how do we engage students in mathematics learning that is interesting, relevant, deep, creative, and lasting? I've been studying that for 11 years formally and 15 years before that, so it's been a long time. Here's one of my teams. This is a Math for Young Children research team, and we're working together. You can see red at the bottom. All of those red topics are things that are featured here at OAME in the next bit. So those are some of the projects. My work is with teachers and students, and we're looking very closely at what they're doing. And so today I'm going to talk about 6 key ideas, I hope. Here we go. The first key idea you'll know well, it's no surprise. Math is important. We know this, but these incredibly huge studies are telling us that math is the best predictor of school success, of math, of language, of social studies. And in following those students over 2 years, it's the best predictor of retention. And yet, look at the Ontario data. We are still spending significantly less time in mathematics each day with our students than we are, for example, in language. And so this leads us to really thinking about what kinds of rich experiences we can offer students. My second key idea is this: young children have tremendous capacity to learn mathematics. This is a kindergarten drawing. The class is studying perimeter, and the student has drawn carpet time, as you can see down the side, with the students all around it. They can play with complex math ideas. This is the students in junior kindergarten and senior kindergarten thinking about linear functions. One butterfly and a growing number of ladybugs each day on the leaf. My third key idea is that teacher efficacy in math is central to student learning. Teacher efficacy is the teacher's belief that he or she has the ability to help students learn. Teachers who have high efficacy persist longer with their students who have challenges, and it leads to positive student efficacy. That is the student's belief that he or she has the ability to learn math. And if the student believes that, then they will take risks themselves in their learning, and they will persist longer with challenging tasks. Teacher efficacy and student efficacy are also related to achievement. They're excellent predictors of achievement, so it matters that we believe in our students. Wow. Okay, the fourth idea is this: thinking about slowing down to speed up. This is a fraction study. We've been studying fractions for, 3 years, and we're going for another probably 3, and it just keeps going. One of the most powerful representations we're working with is the number line, and looking at relative fraction quantities on the number line, and we're seeing the huge longevity and legs of that representation by slowing things down. And that also allows us to have careful observation of how our students are thinking, which is increasing the quality of our teaching and our understanding of how to teach young children. We do use a lot of video, as you can see there. It's one of the features of our work with teachers. The fifth key idea is that concepts and procedures go hand in hand, right? Right, they're not separate. If we separate them artificially, we end up with answers like 5/20ths when we're looking at 5 1/4 containers of water. And slowing down also allows us to build carefully planned pathways that integrate both concepts and procedures. That's blurry because we're not done. But that is going to be a nice pathway of fractions learning, and we're excited about it. My last key idea: spatial reasoning needs more attention. Look on the side where there's 2 black figures. When you mentally rotate those, which do you end up with below the red line? That's spatial reasoning. When kids have opportunities to engage with spatial reasoning, they increase their ability to solve problems, to do addition and subtraction. They actually are better at solving questions with missing add-ins compared to their peers who have some kind of treatment but not that. All right, this is what I'm looking forward to in the next while, continuing with some longitudinal studies of Canadian children, which is sorely needed in the areas of fractions and math for young children. We're also looking at technologies involved. And so if you want to see what we're doing, come to my website, teamwork.ca. We have resources, video, stories, tons of fun stuff. Thank you.